Hi there. Today we're going to look at graphing rational functions. And rational functions are any kind of function that's going to look like a fraction, but it's going to have a variable in your denominator. Okay, so this would be kind of your parent graph of a rational function. And before we get too far, let me go ahead and say this is a big packet, and we are not going to cover all of this in one day. So this video shows multiple days worth of notes. You just can watch whatever you missed or what you're needing extra practice with. Another thing that you need to be sure to have is to have printed out this packet and have this in your hands. There's a lot of graphs, and you need the graphs that go with it. Got to have the graphing packet here before you get started. So maybe go print that if you haven't got that. All right, so to start off with, if I wanted to graph this parent graph, we always go to a table is how we start. So let's create a table here. And if I plug in a 1 for x, I would just get 1 over 1, which is 1. If I plug in a 2, I'd have a 1/2. If I plug in a 5, I'd have a 1/5, or a 10, it's a 1/10. Now, I could also plug in little numbers. I could plug in what if I plugged in a 1/5? Well, if I put a 1/5 right here, I bring it up and multiply by the reciprocal, and it turns into a 5. So let's just plot a few of these, because there's my 1.2 up a half. You know, I can't get them, but I can tell that they're just getting closer and closer and closer. If I put in that 1/5, I'm way up here at 5 somewhere. And so what happens is I create this little curve. And it's just like we call it a branch. All right, but notice that we've talked about this before with fractions. You can't let your denominator be 0. So x cannot be 0. I could not have put that in my x column. And what actually goes there is what we call an asymptote, to show that x can never be that. It's kind of like a holding spot to make sure my graph never touches an x equals 0 value. So this graph will always come and approach that asymptote. Now actually you can kind of tell from my graph that it also is getting closer and closer to the x-axis. So I do also have a horizontal asymptote. Okay, asymptote is spelled like this, just in case you're not familiar with that word. Asymptote. All right. And it just shows what your graph will approach. Now I did all positive values, but I could do the same thing. If I plugged in a -1, I would get a -1 back. A -2, I'd get a -1/2. -5, -1/5. Okay, so I actually have all those same points down here in this quadrant as well. And so you'll have two branches of this. This is actually called a hyperbola, and it's two branches on the graph that are approaching these asymptotes. All right, so that is your parent graph right there. That's our starting point always. Okay, so now we're going to fancy this equation up a little bit. It's not always going to be quite as simple as that one. So sometimes you're going to have a y equals, and this a value, which is a number of some sort, has the same, okay, well, let's backtrack and look at, see how this kind of has that same look. It's got that h and the k and the a. That's what we're going back to, back how we did parabolas and absolute values. It works the same thing with rational functions. So if you remember, let's jot that down. Remember that when we did that with parentheses, with quadratics, like this. Do you remember what the a value does? Okay, it's your vertical stretch or shrink. And so same thing with the a value here. It's going to stretch those branches to be steeper if that's a big number. It defaults to being a 1 in the parent graph. The h, remember, shifts you left and right because it's tucked in with the x. Same deal here. I don't have parentheses around it, but it is grouped together through this fraction bar, and so you still do the opposite, just like you did up here. And then you got this plus k out at the end. On a parabola, it shifts it up and down. Same deal here. The other thing we need to remember is if the a is negative, it's going to reflect over the x-axis. So for these graphs, it means it's going to be in the opposite corners when it reflects over. So let's jot that down. A is vertical stretch. and can also reflect it if it happens to be negative. H is your left and right motion, and it always does the opposite. The K is your up and down motion, and you do what it says. Okay, so let's look at one of those graphs. In this one right here, the 2 is going to have a vertical stretch, so it's going to be a little steeper looking. This -3 is going to move it horizontally. We do the opposite, so it's going to move right 3. This is going to move it up 1. Okay, so what it's really moving for us are those asymptotes that we had. So that asymptote that used to be right on the X or on the y-axis, that vertical asymptote, is going to move right 3. So now I have a vertical asymptote here at 3, which should make sense because x can't be 3. What would happen if x was 3 right here? You'd end up with a 0, and we can't have that. So that's why that asymptote is at 3. I kind of missed 3 a little bit right there, but it should be right on your 3. And then your horizontal asymptote goes up 1 because your k value is a 1, and so you have a horizontal asymptote here. We always dash our asymptotes. Now, the a value is positive, so I'm going to stay in these two corners here as I draw this graph. And just for future, this 2, I know it has vertical stretch. I'm not really going to get caught up on exact ordered pairs for these, so just recognize that's what it would do, but don't get too caught up in worrying about how it's going to look. Just make sure you get it put in these two corners. Make sure you're approaching those asymptotes. All right, there's your graph. All right, I want you to try this next one. Actually, let's talk about it and then you go graph. So, what do you suppose the negative's going to do? Okay, it should reflect it so that your branches are going to be in these opposite corners. That's what that does. What's the +1? Should move it left 1. What's the -3 going to do? Down 3. Okay, so shift your two asymptotes, get those drawn in there, and then decide where you want to put the branches. Pause the video. Okay, so this is what you should have. Notice I moved my vertical asymptote left 1, I moved my horizontal asymptote down 3, and I switched the two corners because it reflected. Now we have a bunch of these that we're going to do, and so I'll do a couple with you, and then I'll turn you loose on finishing the rest of the packet with these types of problems. Okay, so we're going to move pretty quickly here. On number 1, this is going to move left 2, so I take my vertical asymptote, move it left 2. You can just be doing this with me as I'm doing it. And then it's going to go up 5, so I'm going to move that vertical or that horizontal asymptote up 5. My a value is still +4, so I'm going to keep it in those same two corners. Make sure it's approaching your asymptotes. Looks like that. Okay, so the new thing that we're going to add in now is talking about the domain and the range. Now the domain and the range really just come from your asymptotes. We've already discussed you don't want x to be what is going to make the denominator 0, so my domain, x cannot be -2. And I can see because that's where my vertical asymptote is. Well, it's the same deal with the range. I don't want my y, and so it's a y cannot be wherever that horizontal asymptote, I'm never going to have a y value of 5. Okay, let's try one more together. Number 2, this is going to move right 1, down 4. So I put in my asymptote here, right 1, down 4. The a value is a -5, so now it's going to flip, and it's going to be in the opposite corners. It's going to be down here, and it'll be up here, approaching the asymptote. As far as our domain and range, your x cannot be, think about your denominator, you don't want x to be 1, and that's where your vertical asymptote is. And your range is always what you don't want, or what you want y to be, but in this case it's easier to just write what it can't be. Y cannot be -4, because that's where that horizontal asymptote is. All right, so I'm done with this. It's time that you need to stop the video and do the rest of those problems through 8 on this packet. And then we'll start something new. So do that and then pick it up again. Okay, so we're done with that type of a function, and we're going to look at a rational function that maybe looks a little bit different. That type that you just finished practicing doing a bunch of is the type that's really set up like with the A, H, and K business. Let's look at some of these that aren't set up quite that same way. So we still start with our parent graph, and we look at just this 1 over x graph, and that is the one that just looks like this. All right, now what happens if instead of it being a 1 over x, it's a 1 over x squared? Well, I'm still going to have those same two asymptotes, but if you square something, well, it's going to make everything positive. So instead of ending up with this branch down here, when I plug in a negative x value, my y's are going to be positive, so it's going to stay up high. And you can check that on your graphing calculator and see that what happens is you have this normal branch right here, but now the other branch is up top because the squared made everything stay positive. But if you go over here to the next one and it's back to being cubed, now that's an odd power, so it doesn't mind having negatives and it keeps track of that negative, and so you're back to these two corners. And then if you're back to the 4, you'll notice that it's up here. And the 5 is back down here. And so ideally you should be figuring out what the pattern on that is. And so what we'll do is let's jot down what the pattern is. Note the odd and even functions. Notice what happens at x equals 0. So at x equals 0 is this asymptote that we've had on all of these, regardless of whether what's going on. That asymptote is still there. So what happens? When is the graph going to flip across the x-axis, and when does it not flip? Okay, so in other words, I'm coming along here, and then when I hit that asymptote, it flips up here. But on this one, when I'm going along and I'm up high, I stay up high, so it doesn't really flip on that one. So let's jot it down. What do you think? When is it going to flip? You should say, well, it's going to flip on all the odd powers. Sorry, that was messy. Okay, no flip on even powers. All right, so that's an important behavior of these graphs that we'll be looking at. So let's kind of combine a couple of those different concepts then. So if you look at this one right here, remember from that earlier set that if you have something down here with the x, it moves it left and right, and you'll do the opposite. So this is going to move my vertical asymptote to the right 2. So I'm going to have my vertical asymptote here because I don't want x to be 2. I'm going to keep the same horizontal asymptote. There was no vertical shifting on that. That's going to stay the same. Now, and then I'm going to graph it in these two. Actually, let's just to kind of keep this clean, let's go ahead and change colors. All right, so there's my graph. All right, let's look at the next one. Again, I've got this x minus 2 going on, and so that is going to shift my graph to the right 2, so that's still there. My horizontal asymptote hasn't moved. There's no up and down motion here. But what's different is now that quantity is squared. So instead of having these branches like I have them there, they're actually going to both stay up high. And so that's what that type of graph would look like. Okay, you try that last one, and you figure out what that would look like. And fill this in. I guess I didn't really talk about this down here. It behaves like a 1 over x. Where's the asymptote? And I'm saying it flips. Okay, still behaves, now it's going to behave like the 1 over x squared because of the squared. which is keeping these both up here, still have that same asymptote, but it's not flipping because it's squared. Okay, you do all of this. Pause the video. Okay, so check that out. Is that what you ended up with? Hopefully so. All right, so let's just do one more before we jump into this. Could you describe this one right here? We won't graph it, but can we talk about it? So what do you suppose it behaves like? Well, you should say a 1 over x, because see, this is not squared, it's just a linear term, so it would look like this. Where will your asymptote be? Okay, remember it's always the opposite, so it'll be at x equals -3. All right, and will it flip or not flip? Okay. Since it's to the first power, it should be a flip. Okay, so let's do one. All right, so we've got a little bit more going on. If you'll look at what we have here, our in behavior, it's going to behave like a 1 over x squared. The reason is because I have the x term in there twice. It's not the same number this time, it's two different numbers, but it's still going to end up being a quadratic down there. So think about what that means. Okay, I'll have two asymptotes on this one. I have two values that I don't want x to be. I wouldn't want x to be 2, and I wouldn't want x to be 4. So I actually have two vertical asymptotes. Let's go ahead and throw those in there. Vertical asymptote at 2, and a vertical asymptote at 4. All right, now because these are individually to the first power, then they are both going to be flips. So I'll have that to the first and this to the first. So each time I come across an asymptote there, I'll flip from there. So I begin. It behaves like a 1 over x squared. Remember that a 1 over x squared looks like this. So that's how it's going to start, and that's how it's going to end. And I'm going to have some extra stuff because I got these asymptotes in the middle. So it goes like this. Start off here. The horizontal asymptote is still going to stay right there at 0. Comes up, approaches the asymptote. Now, because that asymptote is raised to the first power, right here, x minus 2, raised to the first power, then at that point I have to flip, which means since I'm headed way upward, I'm going to flip down and come down to the bottom on that same asymptote on the other side. So now it's going to be like right here. And then it comes, sorry, it's going to be down here, and now it's going to come up. But here's the problem that I have is I can't cross the x-axis. There's no zeros on this, and so what happens is it just turns around, and it makes like this N-shaped thing. It's just a curve, like an upside-down parabola, though it's not really a parabola shape, but that's the gist of it right there. Okay, so you have to approach that asymptote, which we did, came down here and are approaching this, and then we get to this asymptote, and this is also raised to the first power, so it's a flip situation. And so what that means is since I'm way, way low, I'm going to flip and I'm going to come way, way high. So it's going to come out here like this. And then I flatten it out because this is my behavior. This is my end behavior. It should end at the end look like this thing where it's approaching out there. So that's what I've got right there. There's my end behavior. All right, so this is going to turn into kind of like that polynomial packet, which is fun. Remember the bounce cut packet? And it gets kind of crazy graphs. Same deal with these. Let's try another. All right, we got lots of stuff going on in this denominator. First thing you have to do is figure out your end behavior. You have to count up how many x's there are. So here's 1, 2, 3, 4. So that's why it's going to behave like a 1 over x to the 4th. So my graph will look, it's an even, so it's going to look like this, a bunch of stuff, bunch of stuff, bunch of stuff, and then it's going to look like this on the end. So you can ignore the middle. This is called the end behavior, because out at the end, it should be flattening out, flattening out. Don't know what else is going to go on, but I know that's the end behavior. All right, the next thing that I have to look at is where all of my asymptotes are. So I look at my denominator, and I'm going to have an asymptote at 2. Since it's to the first power, it's going to be a flip. So I'm going to write this like this. And then somewhere on there, maybe way up top, I'm going to put an F for flip, because it's going to be kind of like our bounce cut packet where we put the B's and the C's, because after a while there gets to be a lot of stuff going on. So I'm going to start labeling. All right, the next 0 I'm going to have is 3. So I'll have, not a 0, I'm sorry, an asymptote. And so I'm going to put a vertical asymptote at 3, but since it's to the second power, it's going to be a no flip situation. So I go to the 3, put in the vertical asymptote, and put a little NF up here to show I'm not going to be flipping on that one. And last asymptote is at 5. That one is to the first power, so that's an odd. That'll be a flip. Okay, here we go. Let's graph it. So it has to start off like this. So I'm right here, going along. Approaching this asymptote, so I'm going to head upward. All right, and then this asymptote is a flip, so since I'm way high, I'm going to come way low and start approaching from that side. And then I can't cross the x-axis, so I turn it around. Now this new asymptote is a no flip. So that means since I'm way low, I'm going to stay way low, and I'm not going to flip. And then I come up here, oh, can't cross, so turn it around. Okay, on this asymptote, it's a flip. So since I'm way low, I'm going to come way high. All right, and I'm out of stuff to do, so I look at what was my end behavior. My end behavior said flatten out at 0 there, so that's what I'm going to do. Come down and flatten out at 0. And there's my graph. All right, we're going to try one more, and then I'm going to turn you loose to go practice this a bunch on your packet. Now, we're going to add something to it here. I've got a box over here that I want you to fill in as we do this. And we're going to make sure you put the little F's and NFs so that you keep track of it. And just like on the polynomial packet, no graphing calculators. When you start putting these in your calculator, it's going to be a mess. It will be hard to tell what's going on. It's not going to be beneficial. All right, so here we go. First thing we're going to do is figure out our end behavior. So we have 1, 2, 3, 4, 5. So this is going to behave like a y equals 1 over x to the 5th power. Okay, and x to the 5th, now that's an odd, so if you'll recall what that's going to look like, odds do this, right? And so when I'm doing my end behavior, I'm going to start off below the x-axis, and then I'm going to end up above the x-axis. Now, in here, I'm going to have all kinds of stuff going on. Don't worry about that. You just want to make sure that the ends look like this. Okay. So what that means is as x approaches infinity, what is your y value approaching? Well, since it's flattening out, your y value actually is approaching 0. Let's look at what happens as x approaches negative infinity. You're going this way, and it's getting closer and closer to the y-axis from the underneath side, so it is also approaching 0. Okay, our asymptotes are vertical, so I'm going to write x equals, and I'm going to list where they're going to happen, -1, 2, and 5. But I'm also going to have a horizontal asymptote at y equals 0. And then I have one other thing, and that's to figure out my y-intercept. And to do your y-intercept, you got to plug 0 in for x. So let's see what would happen if you plugged 0 in for x. If you plug 0 in for x here, that's going to become, and I'm just going to come over here and do this, 1 over, I'm going to have a 1. Plug 0 in here, you're going to have -2. Cubed is a -8. Plug 0 in here, and you're going to have a -5. If I multiply that all together, it's going to end up a 1 over 40. All right, so my y-intercept is 1/40. Okay, that's pretty tiny. That's just a hair above the origin. Okay, the main thing I use that for is to make sure that my graph is on the right track and I actually am above my axis at that point. All right, so let's graph this thing. First thing, let's put in our asymptotes. I've got one at -1. It is to the first power, so it's going to be a flip. I have one at 2. And it is cubed, so that's odd, that's a flip. And I have another one at 5. And it's to the first, so it's also a flip. So everything's going to flip for me here. I'm going to start my graph underneath, because it's an odd. Remember how it starts? Down here low. All right, so I'm going to be underneath here, go approach this asymptote and go down. Now, since this asymptote is a flip, since I'm way low, I'm going to flip to way high. Come down here, turn it around at that 140th spot, come back up. So it gets really, really close, but it doesn't touch. Okay, this asymptote is also a flip, so since I'm way high, I'm going to come way low. Come up here, turn this thing around. Now on this asymptote, it's also a flip, so since I'm way low, I'm going to come way high. Way up here, and now I've run out of stuff, so I go back to, how is this thing supposed to end? It's supposed to flatten out at the end. So I'm going to take this thing and go flatten out and approach 0. Okay, there's your graph. All right, so what I want you to do then is to pause the video, and you need to go finish up your packet until you get to part C. That's where the video picks up again. But you need to kind of practice this before you jump into part C, because it gets much more complicated. All right, so here's what we're doing. We're going to be combining the ideas of end behavior, the zeros from the bounce cut packet, and our asymptotes that we learned in this packet. All right, so here we go. You can see now I've got a bunch of stuff going on in the numerator, and so that's going to make it a little bit trickier. Because now not only do I have asymptotes, but I'm going to have zeros. So I am going to be able to cross my x-axis at some places. So if you look through this, let's count up how many x's we have on top. There's 2, 3, 4, 5. So that's an x to the 5th. On the bottom I have 1, 2. So that's an x squared. Now, remember our exponent rules. What would that reduce to? Well, it reduces to a y equals x cubed. Okay, so then that's my end behavior. It's going to be a y equals x cubed. And remember what that looks like. It's going to start low, look like a cubic, bunch of stuff going on though, and then it's going to end high like this. Okay, so that's what your end behavior will do. Let's look and see if this part makes sense. As x approaches infinity, y approaches infinity. Yep, that's going on. As x approaches negative infinity, y approaches negative infinity. Yep, that's what's going on. All right, you're going to look at your numerator to figure out where all your zeros are. So I have a 0 at 0, -3, 4, and -9. Now I've actually already plotted all of those for us with the little B's and C's. Notice this one is to the even power, so it's a bounce. The other 3 are all to the first, so they are all cuts. Then you go to the bottom and you look at where your vertical asymptotes are. You'll have one at 5 and another at -6. Notice I've written that here. They're both to the first power, so they're both going to be flips. All right, and because my end behavior is a y equals x cubed, that's not like having an end behavior of a 1 over x cubed or something. This is not going to have a horizontal asymptote on it. It is going to go to negative infinity into infinity. It doesn't approach 0. All right, as far as a y-intercept, we plug 0 in for x, and so you plug 0 in here, and if you think about it, it doesn't matter what these numbers all are. If I'm going to plug 0 in for x, that's all going to be 0 over whatever is still going to be 0. So I got lucky on that, which I should have known because that's one of my zeros right here. Okay, so let's throw in some stuff. I know that this is a 0, this is a 0, this is a 0. Okay, let's put in our asymptotes. And let's graph this. Okay, so you got to start off with your end behavior. It's a cubic, so it starts low and then comes up. So here we go. Starting low, coming up here. The first thing I come across is a cut. So let's kind of wave through that cut like it typically does. And then come up and it's approaching an asymptote. All right, so this asymptote is a flip, so that means since I'm way high, I'm going to come way low. And then the next thing I'm going to come across is a cut. So come up here and cut. And then the next thing is a bounce. So let's bounce. And then a cut. And then an asymptote. So let's go approach that. And that asymptote happens to be a flip. So let's go way high. And now you have to decide how to finish this thing out. Well, our end behavior says that it's going to finish out like this. And that's not at all what mine is doing. Mine is headed downward. So what you do is you take this thing and you just turn it around. And you head it back up like a cubic is supposed to do. And that's what your end will do. Okay, kind of fun, huh? All right, let's try one more of these before you got to go practice some more. Okay, so here's another example. Let's walk through the box part because eventually you're going to be doing this on your own. So you start off and you count how many x's are on top. Looks like 2. 1, 2, 3, 4 on the bottom. Nothing is to a power here. That's different. Okay, this would reduce to a 1 over x squared. Okay, a 1 over x squared is a rational. So this is what you were doing earlier. A 1 over x squared would look like this. Okay, so forget about, really let me redraw that because it's really going to do this. It's going to look like this, bunch of stuff, bunch of stuff, bunch of stuff, bunch of stuff, and then come out like this. So this part I don't really care about. That's all going to go away. And all I really care about is that this flattens out on the ends. All right, so as x approaches infinity, y should be approaching 0, and same way on the left side, so that makes sense. Zeros come from the numerator, -1 and 2. Let's go ahead and graph those, -1 and 2. Notice they're both to the first power, so they are both cuts. All right, the asymptotes come from the denominator. They will all be flips because they're all to the first power. So I've written out, always when you write your asymptotes, designate x equals or y equals so we know that if it's a vertical asymptote or a horizontal. So I've listed those all out. All right, and then the last thing, okay, and so let's go ahead and draw those in. Those are all asymptotes that are all flips. Not very pretty asymptotes, are they? Okay, and then my y-intercept, if I plug 0 in for all of those x's, here's what I would end up with. Simplifies to a 1 over 193. That's a tiny, tiny number, but it is positive, so I got to make sure that at that point, at x equals 0, that I'm above the origin. All right, let's graph this thing. In behavior says, start off like it's approaching. Oh, you know what? Let's go back to something that I didn't put in there that I want you to put in yours. Because your in behavior has more x's on the bottom, that makes your graph flatten out here at 0, which means you do have a horizontal asymptote at 0. Anytime you have more x's on the bottom like that, you're going to have a horizontal asymptote at 0. So we need to include that in our asymptotes. All right, so let's go graph. So I'm up here, approaching. First thing I'm going to come across is an asymptote, so let's go approach. That asymptote is a flip, so I'm way high. Let's come way low. All right, then it's going to cut and cross through that little spot there. Oh, and then cut. So that just barely got above the x-axis. If you were looking that on your graphing calculator, you would have never noticed that. All right, let's go approach that asymptote. That asymptote is a flip, so let's go way high. Now I don't have any zeros in here, so I can't touch. I got to turn it around. And then the next thing I approach is another asymptote that's another flip, so let's go way low. Come up here, there's no zeros, so don't touch. Come back down. Another flip asymptote, so I go way high. And now I'm out of stuff to do, so I got to go back and look at in behavior says flatten out. All right, let's flatten this thing out. I don't have much room. I suppose you don't either, but it just kind of flattens out there at 0. All right, there's our graph. Okay, so you need to keep practicing and finish up your packet until you get to the next part. The next part that I have, it's going to be horizontal asymptotes. So you need to work through until you get through number 4. And then you can watch the video for horizontal asymptotes. All right, so hopefully you have done the whole packet up to this point and practiced those skills, because horizontal asymptotes are a little bit wormy. Okay, so here it goes. Consider an equation here. Looks like something you've been doing. You got some asymptotes, you're going to have a 0, but notice this 3 that I threw there. Okay, so the end behavior on this one, if you look at it, notice that you'd have 2 x's on the bottom, but you also have 2 x's on the top. So this would simplify to a y equals 3x squared over x squared. The x squareds would cancel, so your end behavior looks like y equals a number. Well, if you think about what that is, that's just a horizontal line. So your graph is going to do something like this. You're going to be up here at 3, and it's going to look like a horizontal line. A bunch of stuff going on, but eventually look like a horizontal line. All right. What that means is that you're going to have a horizontal asymptote right there at 3. That graph is going to go approach, and that's what's going to make it look like it's horizontal, because it's going to get so close it looks flat. Okay, so let's see where I am on my reading. I got ahead of myself there. So horizontal asymptote on the right side. Okay, so here's the problem with this. We're not really sure on the right side if that graph starts from below the line or above the line. Like I drew it so that it was kind of like maybe above the line or something, but it could be down underneath and could approach from that side and still look like a horizontal line at 3. We don't know whether to start above or to start below that line. That's the big problem. We also don't know whether we should start or end above or below the line. So we've got some issues with that we need to clarify. Now, it says to know the graph on the right side, we're going to plug a value of x, which is on the right side, away from all the zeros. So we kind of plug something in that's way out there and see what happens. So typically we're going to use, so compute the value. If we set x equals to 10, okay, so that's going to be our point. We're going to usually use 10, and then we're going to do negative 10 on the left side. If you plug 10 in for x, what do you get back for y? So here's what we got. We put in our 3. 10 minus 2 is 8, and 8 squared is 64. So we got this. Then you put in a 10 here. That's 9 times 5. That's 45. And then we simplify that, and I don't know off the top of my head what that is, but when I divided it all out, it's more than 3. So that means when x is 10, way out on the right side, I'm going to be above that horizontal asymptote at 3. Okay, so to find out on the left side, we're going to plug in a negative 10 and see what happens. Let's check it on our own. They're not going to do it for us. So if x is equal to negative 10, let's plug it in back into this problem. So then I'm going to have y equals 3. A negative 10 minus 2 is negative 12. Squared is 144. In the denominator, I have a negative 10 minus 1, so that's negative 11. And a negative 10 minus 5 is negative 15. And then we have to type that in our calculator. So let me grab my calculator here. I've got 3 times 144. That's 432. And I'm going to take my negative 11 times my negative 15. I'm really just doing 11 times 15 because I know a negative times a negative is a positive. And 432 divided by 165 gets me 2.6. Okay, that's below 3. So that means on the left side, I'm going to be underneath that horizontal asymptote because it's a value less than 3. Okay, so there's a little bit more work involved. Now this is going to happen anytime you have the same number of x's on top that you do on bottom. Now this particular example had a 3 here. It might be a 2 or a 7 or a negative 5, or it might not be there at all. If it's not there at all, we would assume that when these crossed off, you'd get a y equals 1. So you could have a horizontal asymptote at 1 if there's no value there. Okay, so let's do the one that we had just done there. So we had already figured out that on the left side, at negative 10, when I plugged in negative 10, I got 2.6. So I'm going to be underneath that. And on the right side, when I hit 10, I was above that. So I'm going to be here, above the axis, or the asymptote. All right, let's find the other stuff. We've already decided our end behavior is going to be a y equals 3, which means that as x approaches infinity, our y value is going to approach that asymptote at 3. And same thing on the left side, it's going to approach 3. My zeros come from the numerator, so I only have 1. It's at 2. I'll go ahead and mark it. And since it's squared, it's going to be a bounce. My vertical asymptotes are going to be x equals 1 and 5. So let's put those in. Those are both to the first power, so they are both flips. I do have a horizontal asymptote. It's at 3. And my y-intercept, I have to plug 0 in for everything. So I'm going to plug, that's going to be 3. Plug 0 in is going to be negative 2. Squared is a 4. A 0 on the bottom for all of the x's gets me this. So I have 12/5. All right, that's 2 2/5. So it's positive. It's somewhere like right underneath that horizontal asymptote. Okay, so let's graph this. Our end behavior says it's supposed to look like a horizontal asymptote, or like a horizontal line, which is really me just approaching my asymptote. It looks horizontal right there, but I'm underneath. Okay, now here's one big, very important thing, is that you know how if you have a vertical asymptote, you can never touch it? That's actually not the case on horizontal asymptotes. Horizontal asymptotes we are allowed to cross. And so you kind of have to pay attention to what's going on to decide if I want to cross the horizontal asymptote or not. So here I go. I'm coming up here, coming up here. I know this one y-intercept I have to touch. And then I have to decide if I want to go up or if I want to go down. Now normally we would go away from that horizontal asymptote, but here's the problem I have. If I go and approach that, I just crossed my x-axis and I don't have a 0 marked there. So I don't get to do that. I don't get to go down, even though that's tempting. I don't have a 0, so I'm not allowed to do that. I'm going to cross my asymptote and I'm going to go up. Okay, it's a flip asymptote, so let's go way low. Come up here. The next thing I come across is a bounce, so let's just bounce right there. And then it's going to go and approach your asymptote. That asymptote is a flip, so I'm going to come way high. And it looks like based on my point I found over there, I'm going to stay above the asymptote. Now here's what sometimes happens. Sometimes it'll come down below the asymptote, swing up and approach like that. That's what would have happened if we had a point at 10 that was below it. It would kind of swoop down and then come back up. That happens sometimes, but not on this one. On this one, I'm supposed to stay above the asymptote, so I'm going to come out here like that. All right, so there's our graph. A little bit more work involved on the horizontal asymptotes. Okay, I'm going to do 1 with you, and then you're on your own for 2 and 3. So let's look at what we've got here. Starting off with our end behavior, we have x, 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 so that's an x to the third, over x, 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 x to the third. All right, so that would look like it's those both cancel out, so that's my clue. Remember, if you have the same number of x's on the top as you do on the bottom, you're going to have a horizontal asymptote. Notice that I don't have a number out in front on this one. But do you notice one of these factors that looks weird? Right here. All right, that throws a little kink in it because we put this 2x in there. Sometimes that happens. I mean, all of these that we're doing, this isn't reality that these are all perfect, like here where you just have a coefficient of 1. Reality is sometimes you have other factors. Here's how this works. What they actually do on a situation like this is they're factoring that 2 out of there. And remember, when you factor, you're just dividing. So you get x minus 5/2. This 2, they pull out and put it in front. And this is my 0. My 0 is 5/2, which should make sense because remember when we do zeros, we set that equal to 0, add the 5, divide by the 2. Yeah, we do. That should be a 5/2 for a 0, not a 5. Okay, so this does a couple things. So keep in mind that the 0 created here is actually a 5/2, and that by pulling that 2 out, it creates a coefficient over here, so it's really a 2x cubed, which means my end behavior is y equals 2. And so my end behavior is going to be a horizontal asymptote, so that means as x approaches infinity, y will approach 2. Same thing on the left side. All right, vertical asymptotes happen at x equals. Vertical asymptotes come from the denominator, so I'm going to have it at -6, -1, and 7. Horizontal asymptote is going to be at y equals 2. Now in this particular box I don't have the zeros, but I do have zeros. Let's go ahead and mark up our picture. So my zeros are on the top, so that's going to happen at 2. That's to the first power, so it's a cut. And then I have my 5/2, which is really a 2.5, and it's going to be a cut. And then I have a 6. My asymptotes happen at -6, at -1, and at 7. These are all to the first power, so they are all flips. And then before I jump into this, I don't really know if I'm supposed to be starting above the asymptote or starting below the asymptote on either side. So we do these test points. Okay, so I'm going to plug -10 in for x. If I plug in a -10, I'm going to come up here and do this. So if x is equal to -10, I'd have a -12. -20 minus 5, that's a -25, and a -16. On the bottom, I'm plugging in -10, and I get -4. -10 plus 1 is a -9, and a -17. And then I'm going to multiply that all out to see what that ends up equaling. I'm probably just going to go decimal on it, so I know what I'm really looking for is whether it is above or below 2. Okay, I typed that all in and I ended up with a 7.8. So I am definitely above my asymptote at that point. Now I'm way above it, actually. I'm way up here someplace. It's not going to really be drawn to scale, but it's way up here. I'm not very far off from this asymptote here, so that's the whole thing, is that you kind of want to get far away from that to do your test point. We're always going to go to 10 and -10 though, so I'm going to have the same issue probably on this side. That's alright. Let's now go plug 10 in and see what we get. So if I plug 10 in for x, on the top I'm going to have an 8. 20 minus 5 is 15. And a 10 minus 6 is 4. On the bottom, when I plug 10 in, all right, I'm going to my calculator to see what that equals. Okay, that equals 0.9. So that means on the right side, I'm going to be at x equals 10, I'm at 0.9, so I am underneath that asymptote of 2. Okay, so I guess I could fill that in the box here. That was 0.9 and this was 7.8. All right, so let's go graph this thing. In behavior, now don't make this fancy over here and put in a bunch of curves. Really, this is just trying to go out and approach, and then it's going to come up here some way like that. All right, and then I have a flip asymptote, so I'm going to come down low. I do not have any zeros, so don't let yourself cross the x-axis there. It's another flip, so I'm going to come way high. Now on this one I am going to be crossing my horizontal asymptote because I have a cut. And another little quick cut right there. And then I don't really care if I get above that asymptote or not. I'm probably just going to come down here and cut and go down. All right, now it's a flip, so I'm going to go way high, come over here, and now this is the one I was talking about. I'm actually supposed to approach this asymptote from underneath. So that means I'm going to swoop down here and then kind of come back up and go approach from the underneath side. All right, you go try number 2 and 3 and get that figured out before you start the next part. Pause the video. Okay, the last thing we're going to look at is a nice application of these rational functions, and that is looking at the average cost of something. Average cost. Okay, so here we have an example. Carly wants to have flowers delivered to a bunch of her friends. She has to pay $32 up front, and she can have as many flowers as she wants. So for $32, it's a get as many as you want. But she has to pay $1.50 for each flower to be delivered. Okay, so let's write a function that represents the average cost of each flower. So the average cost, I'm going to come up here where I have some space to work. So the average cost, I'm going to do A for average cost. If you think about just in general, what is it going to cost her? She's going to have to pay $32 to get the flowers. Plus, she's also going to be paying $1.50 for each flower she gets, because she's going to have them delivered. Okay, now that's her total cost. But we're looking at what's it cost per flower. So what we would do is we would divide that by X. Divide it by how many flowers she gets. Okay, so looking at that, let's go ahead and clean this up a little bit. We have A equals, I'm going to go ahead and divide both of those by X. So it's going to look like this, 32 over X plus, here the X's are going to divide out and it just looks like $1.50. So this actually goes back to the formula we had at the very beginning, y equals A over X minus H plus K. And remember that this shifted your graph left and right. In this case, I don't have an H value, so it's not going to shift left or right. So it's going to keep a vertical asymptote at 0. That doesn't shift left or right at all. Okay, the next thing you're going to look at is this A value. Remember that made it steeper. Okay, so it's 32. It's going to be pretty steep. The last thing that I have is this plus K. This is kind of important because the plus K moved my graph up and down. In this case, I'm going to have to move my graph up 1.5. So that's my horizontal asymptote that's going to go up 1.5 right here. So I'm going to have a horizontal asymptote, and because there was no negative on that A value, your graph is just going to be up in this corner and up, down in this corner. So this is a good review of that because we haven't done that. We did all these other types. Now I'm going to go ahead and right away erase the left branch because that would be if I had a negative number of flowers, and that does not make any sense in this problem. So in these types of problems, when you're talking average cost, you're only going to be using the right branch right here. And so this is what we are looking at. So on part A, write a function that represents the cost. Okay, I did that. That's right here. Sketch the graph. Did that. What is the meaning of the horizontal asymptote? Okay, so this is important. This is the part that the horizontal asymptote happened at 1.5. And in this problem, that means $1.50. So what happens is that if Carly only buys one flower, let's go over 1, the cost, the average cost of those flowers is incredibly expensive because she had to pay $32 to get one flower and then she delivered it. Okay, so that's great. And so with that one flower, she doesn't really get to divide that flat fee up over like a lot of friends. So as she delivers more and more and more flowers, the average cost per flower is going to decrease because that flat fee, that $32, if she only bought one, that one flower cost her $32. But if she bought, like, let's say 8 flowers, well, then she really only paid $4 for the flower and then had to have the delivery fee. So she wants to take advantage of that $32 for all you can have, so that gets split up a lot. So this 1.5 is what your graph is approaching. It's what your average cost approaches. So as she gets more and more flowers, the average cost for each one of those gets closer and closer to being just $1.50. That $32 that she had to pay gets divided up so many times that it becomes non-existent. Assuming she had lots and lots of friends. If she had, hundreds of friends, well, gosh, you take that hundreds of flowers and divide the 32 out of there. It doesn't cost much. So it's really that delivery fee that's going to cost a bunch for her. That's what her graph approaches. So what is the meaning of the horizontal asymptote? Okay, so we want to write a nice sentence here, and this typically kind of starts off the same way. As Carly buys more and more flowers, the average cost of each flower approaches. That's a big word there. It's approaching, because it's an asymptote, right? So it approaches $1.50. So I'm looking for some kind of a sentence like that for your problem, for you to answer what the meaning of that asymptote is. Okay, now the last question. Estimate the average cost per flower if Carly has 12 friends. Okay, so then you're just going to use your function that you wrote. So you have A equals 32, and you're going to divide it by 12, because that's how many flowers she's going to get, and add $1.50 to it. And then you're just going to your calculator to say, okay, well, if you take 32, divide it by 12, and then add in the $1.50, it's $4.16 is what the average cost would be. Okay, so I have a few average cost problems for you to look through. They all kind of set up this same type of function and divides out the same way, and the graph looks similar. This statement should be relatively similar, and then I'll have you use your function to answer some question. All right, good luck.